Hi there. In this video, we'll learn about the calculations for interest and compare between two different types of interest calculations and two different type of how money earns more money over time. So the generally we represent mathematically here the change of value of money over time by recognizing that there is a present value of the money and there is a future value of the money. So F and P. So P present, F future. So F is equal to P. I can pause here. I have to add the earned interest, and for the sake of simplicity here, we will refer to the earning that have been done over time as interest, because earning can be done in ways beyond interest, like investing in an actual company and what you'll get is return, versus just putting money in the bank and you'll get interest back. So future equals present plus interest. Now the question is how this interest amount over time is calculated. So IN is the interest accumulated or generated over time, n number of years or number of months. So there are two methods: simple interest calculations and compound. So the simple interest is called simple because it's really calculating that amount of earning that's generated based on the original principal. Principal is just another word for the original amount of the money or the loan. So you're just looking backward at time zero how much money I had originally. And now the interest, that's the total interest that's earned in time periods, is equal to the original amount of money, and I represent now my interest, my earning power as interest rate, so it's 2%. So every time period, so it's 2% per year, so every time period here is the year, so every time period I earn P times I, so I earn 5% of $100 per year. Now if I have 5 years, I multiply by n. So that's the IN. So if F is equal to P plus IN, plug in IN now, and we'll find that your Fn, the future value after n number of time periods, is equal to P times 1 plus IN. So let's show that with this table here. Kind of I'm opening the hood, I'm putting my head and look under the hood. If I have like a bank account that's dealing with simple interest, and good luck finding that. Very rare cases you'll find simple interest being used. But like we're looking under the hood and see really what's happening with the money. So in generally economics problem, we don't do that. We use formulas, but this is just to see in action what's being done. So if let's say the original principal amount here is 10,000. So that's the start of the year. The interest earned during that year will be, you have here 10% simple interest. So 10% of the 10,000, that will be 1,000. So the end of the year here, I expect to have in that account 11,000. Now, end of the year balance is the same as the start of the year balance in the next year. So that 11,000 becomes 11,000. So I'm starting kind of the process over. Now this, I have now in the account this, but during the second year, following the simple interest definition, I'm earning interest based on the original principal, which is 10,000. So I earn again 1,000. I add this, I ended up with 12,000. 12,000. Go over another cycle, a third cycle here. Again, I earn the same amount, 1,000. And you keep adding basically every year that fixed earning of 10% of the original principal. Even if your money in the account here is increasing by adding that interest. But your basis of calculating interest is the original principal. So if we apply the formula that we shown before, P times 1 plus IN, plug in the values, and you find that you can actually calculate it that you will have in the account 15,000 without going through that long table. But it's just showing you the under the hood kind of process of calculating or accumulation of that interest. Now, in reality, no one is using simple interest. People are greedy by nature. Like, why if my account has 11, 12,000, 13,000, why you use the interest, or the interest that I get still is based on 10,000? I have now extra 4,000 in my account. Use it, right? Use it to generate more earnings and interest. So that's the idea. Is simple interest ignores that important opportunity cost here. Yes, getting return on my principal interest amount, but whatever earnings I make, I don't get earnings on top of them. So that's the problem with compound simple interest. Now, the compound interest comes and say, let's be really greedy here, kind of, whatever you want to say, but maybe ambitious. So you have an amount in the account, the balance. Calculate your interest based on that current or beginning of the year balance. You don't look at the original principal. So compound interest now, it's not like there is no P in here. It's actually the future value in a year is equal to the future value the year before it times 1 plus I. So let's see that under the hood. So we have here 10,000, 10% per year, but now the rate is compound. So the first year there is no change. Your principal amount is the beginning of the year account value, 10,000. You earn 10% on that, so you end up with 11,000. Now the second year will be different. You start with 11,000, and simple interest is just add 1,000, but now you're adding 10% of the 11,000, so that will give you 1,100. You add that to the balance, your balance moves to the next year, you're adding now interest on, not the 10,000, but now on 12,100. And you see now your interest is increasing over time. And keep going. Compare that to the simple interest amount that we ended up with, which was 15,000. We end up here with 16,105 and some change. So that's the difference between compound interest and simple interest. Compound interest gives you more earning power compared to simple interest. So if we kind of derive now a formula by the principle of deduction kind of, so we're deducting here that you see that you're multiplying always 1 plus I to figure out the amount that's earned. So the interest earned here will end up with always accumulating that 1 plus I to the power number of years that you had before. And you end up here with the future value of a present value P would equal to P times 1 plus I to the power n. So in simple interest, n was multiplied by the I, but now in compound interest, n is the power of 1 plus I. So that's the formula that's actually the heart of economics. It's that future value is equal to the present value times 1 plus I to the power n. So 1,000 now, P, will be more with an interest rate and number of years. So in the future, you expect a higher value of this $1,000. So that's it, just introducing the difference between simple and compound interest. And we will see in the next videos now how to use that simple principle. Once you set it in your understanding in economics that the value of money changes, that becomes the basis for a lot of formulas we'll see to deal with different type of cash flows and analyzing the worth or value of investments or alternatives that have different cash flows over time. Thank you and take care.